Dear students, now start the second part of the chapter Basic MATLAB. In the first part, we talk about vectors, row and column vectors, matrices, the 2 points, and how to refer to rows, different columns, submatrix, element in vectors, element in column, how to change values, and how to delete values and add values and modify the values of vectors. As well as the operations using vectors and matrices, especially addition, subtraction, multiplication, transpose, and so on. And we take this example in the second video. Now in this part, in the second part or third part of this chapter, we talk about the special basic MATLAB functions dedicated for image processing. The first function is imread, image read. Imread means image read, where we read an image. This is cameraman.tif is the name of the image. Cameraman.tif is the name of the image. As we said that the image cameraman.tif is constituted by a set of pixels with C cross R, where C is the number of pixels along the columns and R number of pixels along the rows. So if you want to store this image into a digital system, it will be stored as a matrix of data. So the matrix of data is assigned to the variable A. So variable A becomes a matrix of data, where the size of my matrix is equal to the size of the image cameraman. It means the number of elements in the matrix as row and column equal to the number of pixels in the row and column of the matrix, of the image. Also, the values that can take this, the element of the matrices, depends on the quantification level and the type of colors used. So, cameraman is a grayscale image. So A is constituted of unsigned values, unsigned number from 0 to 255 that represents 256 level of colors, where 0 represent the black color and 255 represent the white color. Of course, any color nearest the 0 is a dark color. Any color, any value or any value nearest 255, it means its associated pixels is a light gray color. Okay, TIFF is a format, a tagged image file format used in graphic artist industry. So after reading the matrix A, if you want to determine the size, we can use a function size. We have in MATLAB the function size that return the size of A. If A is a number, return 1, 1. If A is a vector, return 1n or n1, assuming A is a vector, row, or column. And if n is a matrix, so the n has 2 values, number of rows and number of columns, which is the dimension of the matrix. Display these 2 functions return the numerical value of a variable. If A is a variable, is a variable that take 1 value, it returns this value. If A is a vector, it returns the value of the different elements of the vector. And if A is a matrix, it returns the different values of the elements of the matrix. Who and whose it display the list of variable in the workspace. We have used who in the first video. Whose is similar to who, but in addition to the list of variable, we defined their format. It means if this variable is a single value, or vector, or matrix, or structures, and so on. Okay, now image file info generate information about the image. For example, image file cameraman.tif, it returned the information about this value. What means information? It means file size, format, width, height, size, color type, etc., and many other information. Of course, you can in the workspace of the MATLAB write image file info cameraman.tif or greens.jpg and find out the different information generated by this function. A plot. First, to plot A to point, it means that we talked about this in the first video. A to point, we transform the matrix A into a column vector constituted by all the elements of the matrix, and this vector is constituted column by column from the matrix. So plot A, just it's a Cartesian system when we have the different values between 0 and 255 as ordinate, and the abscissa are, since we have just one variable, show the abscissa is the number of element as abscissa. Since we are working on cameraman.tif, which is a gray level associated to 8-bit, so all the values are between 0 and 255, which is the grayscale level used. And if we look to the values, when we have values nearest 0, it means that this pixel of the corresponding pixel is dark or nearest the black color. If we have higher values nearest the 255, it means we have white color or light gray color. Image show A, if we have a matrix A of image, it's a 2D array or a matrix that conform to the intensity or color range. It means it's the value of the in this array is correspond to conventional values used for intensity of image or color range. Image show just display the image. The range should be 0 or 1, between 0 and 1, which is color intensity, or if it is grayscale image, between 0 and 255. Now, image scale can accept any kind of values of range, assuming that this, the range of data or the values either unsigned integer 8, which means values between 0 and 255, or values are double. And in this case, image scale, SC, it means scale. It's a scale the values of the image between 0 and 255, or between black and white. Image A also display the image, but with the scale is colored. Color bar, it give a bar that represent the different colors with different levels. Axis image, we put control the axis scaling and appearance of the image. Axis off, we delete the axis of the image. V equal axis, we assign a vector V to the scaling axis. Axis X min, X max, Y min, Y max, we rescale the image plot between these values. So we make a zoom for the image between X min and X max and Y min and Y max. Color map gray, it means that we display the image in grayscale, and the size of color map is 256 times 3, since we are working on the image cameraman. Color map, we can select a color map or specify the color intensity as 010, 100, 010, etc. to define the color intensity. Okay, let's take an example. Let's take C equal random 256 times 1000. So the function rand generate a number between 0 and 1. Exclusively, it means we can have 0, but can't have 1, because 0.0000 is considered as 0, and 0.9999 values. So if we multiply these numbers times 1000, of course, we run 256, this number, it means that we create a matrix of dimension, a squared matrix of dimension 256, where each element of this matrix contains a random number between 0 and 1. So I create a squared matrix of dimension 256 as number of row and columns. This is the matrix. And each element is between 0 and 1. So when I multiply by 1000, all the elements now are between 0 and 1000. So when I make image show, the majority of variables are greater than 255 because we multiply by 1000. So the majority of numbers are in the range around 255 and greater than 255. So for that, when we make image show C, we saw that this image as white because all the color are nearest to 255 with the small numbers less than 255 that are as a small noise in the image. Now, if I use image scale, image scale, so in this case, we make a scale for this image. It means we take the minimum numbers in the matrix and we scale it as 0 for black, and the maximum number we scale it as 255 as white. In this case, we obtain a similar image. This is the image that we obtained. So we saw the difference between these two images. This is a scaled image with this. This is unscaled image with this scaled image. Now I can make a color map gray just to show the image in gray color, not in colored color. So for that, I use color map gray color bar. Now, if I want to use image show, but using to be scaled, so I can use image show, see the image, comma, I put here the minimum scale and the maximum scale. So image show C0 1000 is similar to image scale. Okay, let's take a function, bimread cameraman.if. This is the image cameraman.if. And size B, this is 256 and 256. This is the size of this image as number of pixels. Now, for I equal 1 to n, this is the loop for using in MATLAB. This is how we write the loop for in MATLAB for I equal 1 till n. Because 1 to n, you remember that when you put 1 to point n, it means 1, 2, 3, 4 till n. So for I equal 1 to n, for j equal 1 to n, Cij, which is any element in the C, equals Cij plus 60. So we add 60 to each value. Now, if Cij exceeds 255, we put Cij equal to 155. Why would we use this? Because as you know, the grayscale level is between 0 and 255. So any value higher than 255 is not in the quantification level. So for that, the maximum is 255. So any number exceed 255 will be set as 255. Of course, to AND for and if, we use the terminology AND. Okay, it's not here braces, we use AND, as in the GBasic. Now, what's happened if we add a number to the colors? So if we have a color, for example, 40, and we add 60, so it's 100. What is its impact on the image? In fact, as we know, lower values mean black colors. Higher values mean light colors. So if we increase the values of each pixel, it means the image becomes more lighter than the original image. And this is image show for the image C and B after changing. And we see that in this image, the color are lighter because we add 60 to each color. This is black, this is dark. These are gray, it becomes more white. This building is gray, light gray color, it becomes white because when we add, if it is, for example, 200, and we add 60, so it becomes 260, which is maximized, or the maximum level is 255, which is the white color. Of course, now if we put, instead of plus minus, the obtained image will be more dark than the original image. So you can test this code, and you can use either instead of plus minus, and if Cij less than 0, Cij equals 0. In this case, the obtained image will be more dark. The darkness will be more on the image, more dominant on the image. Okay. Now cmread onion.png. This is the image onion.png. Also, PNG is a portable network graphic that replaces GIF, and it's used to send image over internet. So it's lossless compression format over internet. So we talk about mread. Also, we can find the size. Now, onion is a colored image. It's not a gray level image. So it has the dimension R times C times 3. Why we have times 3? Because we have one matrix for red, one matrix for green, and one matrix for blue, because we have the RGB system. So C red, how to find the red matrix is 2 point, it means all row, 2 point, all columns, 1, it means the first matrix. C green is 2 point, all rows, all columns, it means all the matrix, but the matrix number 2, and C 2 point, 2.3, it means the matrix number 3. So in this case, we can find the matrix. So we have 3 matrix. This matrix is the green. We have the matrix red. This is the red matrix, and we have the blue matrix. This is RGB. And every matrix is constituted by row and column. This is the first matrix. This is the second matrix, the green one. This is the third matrix. Of course, each one is of dimension C times R. Now, this element, number of rows, it means we write here, we talk on these rows. The second, it means we go on the number of columns. And this is 1, 2, 3. It means 1, we are in the red matrix. 2, we are on the green, or read the green elements. And 3, we read the blue matrix. So to read, to have all the red matrix is 2, 2, 1, 2 point, comma 2 point, comma 1. We have the red channel. We call it red channel. To extract the green channel, it's the second channel. So C 2 point, comma 2 point, comma 2, the second, and C blue for 3. In this case, we have 3 matrices because it's a non-RGB color. Now, if we have 3 channels, red, green, blue, how can I obtain the original? I cannot directly use image show, because I have three different matrices. So use a function cat. It means concatenation. Concatenation. This is the number of matrices, and this is the red channel, the green channel, and the blue channel. In this case, we can reconstruct the image onion.png, and we can use image show or image sec or image to show this image. Okay, let's take now the function image read cell.tif. This is the image cell.tif, but this is gray. Now we display the value C2550. 2550, it's a point here. Okay, so its value should be between 0 and 255. If we take C250, 2550 equal to 155, what's mean? It means that we have a point. This point, 1 pixel, is changed to be white. So assume this is 25. This is 25. Well, this is 50. So we'll obtain just 1 point in the image. So we'll obtain just 1 point. This lead to this. So see 2550, the pixel 2550 becomes white. So if I make image show, I just see the image with 1 point or 1 pixel that is convert to a white color. Now to increase the size of the white, I take a block of data, 25, 35, 50, 60, which is 11 pixels by 11 pixel, because 25 to 35 give me 11 elements, 50 to 60, 11 elements. So we have a square value element by element, which is constituted by 11 elements. And this value is given to 255. Now, the function ones create of matrix that all the elements are 1. For example, 1 to 3 give us a matrix of dimension 3 by 3 formed by ones, only ones. And 3 is the dimension of the image. This is 1 to 3, formed just by ones. So if I use 1's 11, it means we have a matrix of dimension 11 by 11, which is the same as this block of submatrix. All the elements are 11, are 1. Now, if I multiply by 255, so each element becomes 255, because here we multiply the image by a scalar number. So each number becomes 255, 255, 255. Now, when we make image show, so we will obtain this block of image, block in the image. Each pixels is converted to white because its value becomes 255. So in this case, we change, or we make a white cube or white square in the image. And this square has a dimension 11 pixels by 11 pixels. And this is from 25 to 35. It means from row 25 to row 35. This is row 25 to row 35, and columns from column 50 to column 60, which is this submatrix. Of course, if you multiply this by 0, either than 255, so this block will becomes black. You can do this using MATLAB. After showing this cube or this squared white block, you can use C25, 35, 50, 60 equals 0 times 2 1's 11. So in this case, all the element becomes 0. And when you write image show, this block will become black. Now, this is image read cell. And what I did here, I write my name by using these examples. I take this column, is white, this row as white, this column as white, this columns as white, the point this as white, column white, row white, and I write my name in the image. So I will give you a homework. Your homework is to write your name either in Arabic or in English, to write your name by taking this as I take, by writing, transforming different rows or columns from their original colors into white color until you obtain your name on the image. And I will ask you to send me the code, this code, C equal mread, C, etc., 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 image show, and when you see image show, make on the image file copy image and send me a copy of this image and using this code. So it's a homework for you in the next few days. Okay. cmread equal onion png image show. This is onion.png. Now display C2552 point. So display, what is means is display? It means we give the value of the variable. C2550, it means the row 25, the column 50. 2 points, it means all the matrices. This pixels in all the matrices. The matrices that are sticky together. So remember that we have R, G, and B. 3 matrices to represent the element. So to C2550, this is the pixel 2550. This is the element, have 3 components. One for the first matrix, R, the second for the second matrix, G, and the third for the third matrix, B. So we have 3 values, R, G, and B. Okay, so 3 values for red, green, and blue. C2551 is for red value at position 2550. C2550 for green values, also at the position 2550. And C2553, it's a blue value at position 2550. So we have 3 values concerning the position 2550, because here we are talking about RGB color, where each pixel takes 3 values. Now, if we continue, if we put C2552 points equal 25, 25, 25, why we are using 3 values? Because C2550, 2550, comma 2 points has 3 values, RGB. So to change this value, I have to change it by 3 values. So I put 255, 255, 255, which is a white color. And if I make image show, I will remark that we have, I remark that we have 1 point, 1 white point on the image. This is the white point. This is the white point here that is added to the image. We convert the original color of the pixel 2550 into a white. So we see just we have 1 dotted white in this position. So this is here the dot point. Also we can, as we made for the previous image, either instead of changing just 1 pixel, we can change a block of pixel. And by changing a block of pixel, we can we can see, for example, a white block in the image. Let's say we can see this like this. We can see a white block like this in the image. So you can change here rather than user 1 pixel, we can use different pixel. For example, 25 to 35, 50 to 60, equal in this case 255. I will write it here. C 250 to 35 and 50 to 60. We will obtain 255 times ones and ones, as we said, it gives a matrix is formed of ones. And the dimension of the matrix is 11 as number of rows, 11 as number of columns, and 3 because we have 3 matrices stacked together. So in this case, we can write C to 25 to 35, 50 2 point to 60, comma 2 point. So this, as we make here, as we make in the previous, as we make here, this is 25 2.35, 50 2.60, comma 2 point, equal to 155 times ones. Rather than obtain 11, we have 11, comma 11, comma 3. In this case, we made a block of white of dimension 11 pixels as width and 11 pixels as length. Okay, we will continue. Here I read the onion.png, which is the same image. This is onion.png. And I create a block, white cube block, that is moving on the image. So we create a white block, that this block will go from the left side to the right side, then it's decreasing or moving down, then is moving from left to right, moving down, moving from left to right until arrive at the end of the image. So in this example, you can make this example using MATLAB as it is. We have using just 2 new functions, image to frame. This is image to frame, M of K, should be used after with image to frame should be used with movie M. So now we take different image, and by using image to frame, we transform this frame together to make a movie. So as we said, when we are talking about the resolution, temporal resolution, we said that any movie is a transition of different image. Now we can make, by using image to frame, different frames or image, and by using movie, we can show this movie by transition of the different image. So you can apply this on your on the workspace of the MATLAB and see what's happened, and you will show a white cube moving on the image. In the other example, also we use image read and image to frame and movie, but now we have white cube plus black cube moving on the image as a chess. You know, as a board of chess, we have white, black, white, black, white, black, and so on. So for this, we used ones, and we use a function. The new function is zeros. What means zeros? Zeros is similar to ones. but rather than the elements are 1, all the elements are 0. So if we write zeros 2, 3, zeros 2, 3, we'll obtain a matrix of 2 rows, 3 columns. All the elements are 0. This is zeros 2, 3. 2, 3, it means the dimension of the matrix, and all the elements are 0. So 0, 10, 10, 3, we create a matrix of dimension 10, 10, and 3, 10 rows, 10 columns, and 3 stacked matrices, and all the elements are 0. So when we have a value 255, it means white. When we have a value as is 0, it means black. So in this case, we create white and black, white and black, white and black cube that is moving all the image. So you can test this using your command window MATLAB. And of course, here we use the function mode. Every function that is used in MATLAB, write it in a different, please make a small paper note and write every new function that we met in MATLAB. Mode K2, this is the modulus. It means in C or Java, this similar to K modulus 2. K percentage modulus 2. If K modulus 2 equals 0, so in MATLAB we have the function modulus. Mod, yani modulus K2 would give the remainder of the Euclidean division. So in this example, we have the mod. This is new function. Zeros is a new function. Ones, we have seen this in before. Image to frame and movie, we have seen it in the previous example. So I will ask you to use a note, and in this note, put any new function that you will use in MATLAB, and make it as a remarks to remember it when we have to use it another time. Okay, now we have image view. See imread cameraman.tif image view. See this function. It depends on the type of or version of MATLAB. Image view is not existing in all MATLAB versions. So maybe image view is not is undefined in your version. But if you use image view, this is image view of any image. We see the pixel. This is a pixel 8, 9, so it's dark. 90 becomes darker. 127 becomes more light. 160 becomes more light. 200 becomes lighter and near the white. So this is a pixels value of a gray level image or grayscale image. Now, if you use for onion PNG, which is RGB, remark that each pixel contains 3 values, R, G, and B. For example, this R75, G90, B36, R72, G87, B29, and so on. So this is how we, the pixels value. In gray level, we have one matrix, and values are between 0 and 255. Y for 3D RGB colored image. For each pixel, we have 3 values, and one for red, one for green, one for blue, and each value are between 0 and 255. Okay, this cameraman.tif. If we make the difference vector, this is difference, which means the difference. It means that we have a columns, we differentiate each element from the others. This is difference vector. Difference vector, if we have, for example, V equal, let's say 3, 5, 7, or 17, 28. So difference of V, what is this? It's the difference between each two consecutive element. So we'll obtain 5 minus 3, 2. 17 minus 5, 12. 28 minus 17, which is 11. And so on. So this is what we call the difference vector. Each element in the vector is replaced by the difference of two consecutive elements. Now, what is the objective of difference vector? Okay, if we have why is use a difference? So if we have two dark colors, so these values are have same values, approximately the same value. So while we differentiate between these two values, we will obtain value nearest zero. Also, if we have two light values, the difference between them also will be nearest zero. So if we have, for example, two dark values, let's say we have 40 and 48. These two values are dark color, so the differentiation between them is 8. Now, if we have two light color, let's say 212 and 221. So 212 minus 221 in absolute value is 9. Also, the difference is 9. So the differentiation between two black colors is approximately 0 or nearest 0. And the differentiation between two light colors also is approximately 0. Now, when we obtain the difference is high, is when we have 1 pixel dark and 1 pixel light. For example, we have a dark pixel 40 and light pixel 220. If we differentiate between these two values as in absolute value, so the differentiation between them is 180. So the objective of making the differentiation is to define what we call the edges. The edges is the borders between the two zones, light zone and dark zone, because the difference in the light zone is 0 or approximately 0. The difference in the dark zone is approximately 0. And the difference between light and dark or dark and light is higher than 0. So when we make image show or image scale of the image, the white colors or the white colors, it means here it's a difference between one dark with one light or one light with one dark, which give us the border of the image that differentiate between the different parts of the image. And of course, we can change this using 30 or 40 or 10 with this is what we call thresholding values, that if the values is greater than 30, we put it as white color in order to obtain white and dark color, a white and dark image. So in this case, we saw that just these values, when we have the white, is the difference between the light and the dark. Here we have dark, we obtain just zeros. And here we have light, we obtain also 0. Here is the difference between white and dark, which is the camera and the fields behind the cameraman. And according to the value 30, 40, 10, we can generate more image and observe which image is the best and can give more details about the different part of the image. Now, CM Read Greens, another application. If we use image write, it means we save the image. We have C as image, matrix, So we save the matrix C and give it as a name. So here we call the GPG greens dot JPEG of type JPEG. And also we save the same matrix of type PNG greens with type PNG. So we have same matrix C, but we save this image with different format, one for JPEG and the other for PNG. JPEG has most quality better than PNG. PNG for lossless compression, and it's used for transmitting this image over network and over the internet, so the quality is not the same. So if I want to show these two images doesn't have the same values. The values will change. So let's consider that we read the image again. GPGGR, GPN greens. We read this image, one of type JPEG, one of type PNG, and we make the image abs difference. Image absolute difference. It means just we differentiate between the two matrices, because this is a matrix and this is another matrix. Just we make the absolute difference between the two images. And this image K is showing that if these two images have same values, we will obtain a value 0. The difference will be 0, and we'll obtain a dark image. But here we don't obtain a dark image. We obtain values. We have the black, we have the gray. Of course, the scale is between 1 and 50, so obtain values here white. So we have elements that are different from 0. So which means that the PNG values has changing the value of C. C is the same as in JPEG, but by saving it as type PNG, the values have changed. Why? Because using PNG, the quality is less than the JPEG. And these two types doesn't give the same pixel values. Okay. Okay, we'll go faster than another application. So let's say we have imread onion.png, difference A. So you know what is the difference in each column. Now, if I want to read only that IJ1, what's mean IJ1? It means 1 means the red channel, because you know we have DIG1 for red channel, DIG2 for a green channel, and DIG3 for blue channel. Now I make the same as I made for the cameraman, but now we have 3 matrices. So I make this difference just for the red channel, and we will obtain this image by using image show. This is the onion. This is the image onion here. This is the onion, and we make the difference. We show these values because it is the difference between the different colors. So for that, we obtain this, which approximately is the border between the different parts of the image. Okay, this is the onion, this is the pepper, etc. This is the pepper, and so on. Okay. Also, if we use 1, 1, we use 2, 2, we obtain, this is the red channel, we obtain green channel. And if we use 3, 3 also, we obtain the blue channel. Now, image onion, we can transform any RGB color into grayscale by using the function RGB to gray. So this is a new function, RGB to gray. We transform that RGB color image, which is constituted by 3 matrices into one single matrix, but in grayscale image, using the function RGB to gray. So this is the RGB colored image, and this is the grayscale image. And here we're using the subplot, we draw that image. Okay, now we have used the subplot. What means subplot? Okay, subplot, this is M, this is N, and this is I. So subplot M and I, what does it mean? Subplot MN, it means we create M cross N images. So 2, 1, it means we have 2 images into 1. So we have 2 rows, 1 column. 2, 1, it means 2 rows, 1 column. 2 rows, 1 column, and each element is an image. And I is the number of image. So if I want to draw in the first scale, in the third subplot, I use 1. If I want to draw in the second subplot, I write 2. So for that, here we have 2. Title, it means I put title here. This is the title of each image. So I use titles, and with quotation, colored image, or grayscale image, this is the second title. Okay, this is a subplot. Okay, let's talk also about subplot because it seems it's not clear for you. So I assume that we have subplot. Two, 3. 2, 3. 2. What means subplot 2, 3? It means we have 2 rows, 3 columns. So this is a image, 2 rows and 3 column. Row 1 and row 2. This is a row, column 3. And this is, we have 2 rows and 3 column, 1, 2, 3. So we can write 6 images on the same plot. Image 1, I1, I2, I3, I4, I5 until I6. So this is I1, I2, I3, I4, I5, I6. Now, if I want to draw in this, if I want to draw here, so just I put 2. Subplot 2, 3, 2, I write the image here. If I want to draw here, my image, I write subplot 2, 3, 5. And after that, I use a plot to, or image show or image sec to show my image here. In this case, I can, using subplot, for example, 2, 3, 2, I can have 6 images. And after writing subplot 2, 3, 2, I use image show or image scale or image, and the image will be displayed in this, this screen. And in this case, I can show 6 images in the same subplot, in the same plot. So this is subplot 1, this is subplot 2, subplot 3, 4, 5, and 6. So just to be clear about subplot. Okay. D red, D to point, comma to point 1, this is a red channel. D green and D to point 3, this is a blue channel. So we talked about this before. Subplot 2, 2, it means we have 2 rows, 2 columns, so we have 4 plots. So this is 2 by 2. This is 2 by 2. 2 to 1, image show D. So D, this is the original image. So here we have the original image with title original. And after that, we have subplot 222 with a red channel. So here the red channel will be displayed here. The green channel 223 will be displayed here with title green. And finally, the blue channel will be displayed here with title blue. So here we have title original, the first quadrant. The second quadrant will title red. The third with title green. And here with title blue. Here we have the original image. Here we have the red channel, the green channel, and the blue channel. Okay? And this is the obtained images. This is the original, as we said. This is 2 by 2. This is red, green, blue as title. And here we have the red channel, the green channel, and the blue channel. Okay. Now, we have A0 size 1, size 2. This is, we create zeros that have the same size as C, because we know that size of C1 gives the number of rows, size C2 gives the number of columns. So we create a matrix that have the same size as C, but all the elements are 0. Only red, we concatenate 3. This is a 3 because we concatenate 3 matrices. We take only the red channel, and the other channels are zeros. The blue and the green and the blue channels are zeros. For green and for blue also, we make the same things. Only the green channels, we take C2 to point, comma to point 2. The red is replaced by 0 and the blue is replaced by 0. And also for only blue, we have red channel, green channels are also zeros. Just we have the blue channels. And we make a concatenation to construct the image that is constituted by 3 matrices that is stacked together. Now we make a subplot 2, 2, as we said, 2, 2, 1, 2, 2, 2, 2, 2, 3, 2, 2, 4. So we obtain 4 images, title original, red, green, and the blue. So we'll obtain this. And this is what we call the filter. This is the red filter. Just we have red channel. And the green and the blue channel is 0. So we obtain an image with a red background. The green, we have the red channel is 0, the blue channel is 0, only green, the channel have values, so we obtain the green with background green, the image with background green, and the same for blue. Now, if we mixed colors, we know, for example, yellow is the mix between red and the green. So I take red and the green will obtain yellow. Red and the blue will obtain magenta. Green and the blue channels without red, because it's 0, will obtain the cyan. So just we create 3 other filters. 3 other filters. Also, we use same axis 2 by 2 and with original titles. This is a yellow channel. This is the magenta channel. This is the cyan channel. Okay, it's because we merge red, green, green, and red and blue, and green and blue. Finally, to go to the space HSV, we cannot display the image in type HSV. So image read, this is image read onion.png RGB to HSV. It's a new function. You can write it. This function transform RGB into HSV. So we'll obtain a matrix, 3 matrices, one for hue, one for saturation, one for value. This is for the color system HSV. So to transform the color space from RGB to HSV, we use the function RGB to HSV. And also we can write H alone, X alone, and V alone. And this is the hue channel, which give the intensity of different values. The saturation channel gives the purity of the channel of the colors, and the value channel give the quality of the colors. This is hue, saturation channels, and value channel. Now RGB to HSV, if we make any change on RGB on H or S or V, for example here, D is RGB to HSV. Now DIG1 is H hue channel or hue value, hue matrix. So we change the value. If DIG greater than 0.5, so DIG1 equals 0.5. So just to make a change on the H value, H matrix. Now to see what's happened to the image, if we make this changement on the image, we cannot showing D directly. We have to retransmit or make a reconversion, convert again HSV into RGB, which is a complement conversion. Here we convert from RGB to HSV, here from HSV to RGB. And when displaying the image, this is the difference between these two images. This is the original. This is when we take all the elements greater than 0.5 are set to be 0.5. So here this has make a change on the color, the red colors here. Now, if we make a change on the second matrix, which is as saturation, so we saw that the image is not what we call is not the quality of the image is not good, as we have a fifth colors. And here, when we change the third image, which is value, HSV, V value, if we change the value, which value is greater than 0.3 is set to be 0.3, and we return to the RGB space, and we display the image, we obtain this image. And we show that the colors are not, the quality of the image is not good. The colors are not good.